Hi, folks. We are on our last lesson of the chapter already. I feel like this chapter went so fast. But area of similar figures. So we've spent all chapter finding areas of all kinds of things, right? And today we are going to actually see if we have some shortcuts or some properties that we can learn about area of similar figures. Okay. So let's take a minute here to review what are similar figures. This is, I don't know, 3 chapters ago, 2 chapters ago, sometime after like January, Christmas break-ish. So a similar figure is when you have corresponding angles that are congruent and your corresponding sides are proportional. So remember, your angles are exact same. So angle A here matches angle D. They're both 36. B matches E and C matches F, right? Your angles are the exact same. However, your sides aren't well, they could be the same, but typically they're not. But they are proportional, meaning what number do I multiply 4 by to get to 8? Well, I multiply it by 2. So that means if I take 5 times 2, I need to get 10. And if I take 2 times 2, I need to get 4 in order for those to be similar, which they are in this case. Because remember, your sides need to be enlarged or shrunk by the same value in order for them to be similar. Okay? So just remember, similar figures are the exact same shape, but one is small and one is big. Now today we're going to talk about their areas and some shortcuts on how to find them if you're given one or the other. So if we just use this example here to kind of get us thinking in the right mindset, let's find our scale factor. And you guys know I'm weird and you guys know I have my issues, but if I had my choice, I'd always put the smaller one on top. So I'm just going to match 5K. So what matches 5K on our bigger rectangle here? Well, it'll just be 5. And remember, your scale factor, you always want to reduce. So what's going to happen here is, well, those 5s are going to say smell you later, and we're just left with K. Perfect. So let's now try our perimeters. What is the perimeter of B? Well, 5K plus 9K is 14. We have 2 more of those, so 14 times 2 is 28. So 28K would be the perimeter of B. And then 5 and 9 is 14, and we'll multiply that by 2 because there's 4 sides. So let's get 28 for figure A. And oddly enough here, what happens to our 28s, kids? Again, smell you later, and we're just left with K. Very interesting. Now let's look at their areas. How do you find the area of a rectangle? Well, you take base times height, so 5K times 9K would give us 45K squared. And then for figure A, 5 times 9 is just a simple 45. Ooh, what are we noticing? Again, those 45s go away, and we're left with K squared. So now if we look here, as the smart individuals that we are, our scale factor is the exact same as our ratio of our perimeters. They're the same. That's something I'd probably want to keep in my memory bank. They're the exact same. And if I wanted to find the areas, the ratio of my areas, we just take your scale factor and we square it. Crazy. So those are our shortcuts today. And we're going to have just a bunch of problems dealing with these ideas. So if we wanted to fill in these blanks here, it says, if 2 polygons are similar with a scale factor of A to B, so it's number over a number, then the ratios of their areas is A squared to B squared. So if we know this, we can get here. Or if we start with the ratio of our areas, I'll teach you how to get to your scale factor. It's kind of cool. But make sure you get this down. This is the heart of the lesson, is just this big idea right here. For each pair of similar figures, find the missing area. Okay, so in these problems that you'll see today, you're going to be given basically a side of both of your similar figures and then the area of one of them. And you're going to have to work your way to get the area of the other one. That's what's happening in this example here. So what I like to do is give yourself a little roadmap. So we're going to start with your scale factor. What is our scale factor? So pick matching sides. So what does 5 match? Well, 5 matches the only other thing we have is 8. So 5 over 8, okay? And now you need to get to the ratios of your areas, okay? So now your little roadmap's telling you to go to your ratios of your areas. I'm going to abbreviate it with this, ratio of areas, ROA, okay? So we just learned that the ratio of your areas is a squared to b squared. Well, we already know our scale factor right here is a to b, and I want to get to a squared to b squared. So easy enough, kids. All we have to do is square both of those. And that's the ratio of our area. So 5 squared is 25, and 8 squared is 64. And now from here, we're going to write a proportion. Write your proportion to solve. Okay? So we're going to start with your proportion of 25 over 64 is equal to, now what are we looking for? Do we know the area of our smaller figure here? Nope, so that's our x. And I know it goes with 25 because that represents my small over what's the area of the big one? 32. And now we just simply cross multiply. Okay, so we're going to have 64x equals 25 times 32, which is 800. Divide out, x equals 12.5 centimeters squared. That's it. Okay? So I think it's helpful. I mean, these are just me, but I do things kind of weird too. Writing yourself this roadmap, remembering a over b equals a squared to b squared, it all helps. Don't try to do it in your head. You're going to get lost. I promise there's a reason why I do what I do. Okay, let's try another one. Okay, we're finding the missing area, so this is what we're looking for. We're looking for the area of this one. We don't know what it is, so we're just going to call it x. Okay, so step 1 we said was find your scale factor. So that's our a to b. Okay, and again, I'm going to put my smaller one on top. Okay, so I'm going to have 6 over 8. And then remember, you want your scale factor to always be in simplest terms or reduced. So I'm going to reduce that to 3 over 4. Okay. Now from here, write the ratio of your areas. So remember, that's when we square those. So we're going to get 9 over 16. And then from here, write your proportion. So we're going to have 9 over 16. Now remember, since 9 is a smaller number, we want the area of the smaller one on top, so 13.5, over the area of the bigger one, which we don't know, so we're calling it x. And now we simply just cross multiply. We'll have 9x equals 216. Divide out, x equals 24 feet squared. Okay. All right, folks, now we're going to go backwards. We're going to try some examples where we're given the areas and we want to find the scale factor and the missing side length, okay? It's very similar. We just kind of switch up 2 of our steps, the order of them. So again, this time we are looking for the scale factor and the value of x. So this time, instead of starting with our scale factor, we're going to start with the ratio of our areas. And again, I'm going to put the smaller one on top. So what's the area of the smaller one? Well, they're telling us it's 50. The area of the bigger one is 72. And you do want to see if you can reduce because it will make your life easier. So I'm thinking, what number goes into 50 and 72? 2 does. I think 2 might be the only one. So if we reduce these both by 2, we'll get 25 over 36. Okay, now from here, we want to find our scale factor. Now, folks, think about it. If I had a squared, how do I undo something squared? You just take the square root. So now this time, instead of squaring those numbers, we are just going to simply take the square root. What is the square root of 25? Well, that's simply 5. Square root of 36 is 6. So we found our scale factor to be 5 to 6. And then from here, we write our proportion to find our missing side. So we're going to have 5 over 6. Do we know the smaller side length? Nope, it's our x. And then our bigger one is 6. So we're going to have 30 equals 6x. Divide out x equals 5. So we wanted to maybe organize this a little bit more here. The answers we were looking for, our scale factor is 5 to 6. X equals 5. That's the side we found. Perfect. Let's try another one just like that. So again, we know the areas of both these, so you're going to start with the ratio of your areas. We're going to have 64 over 400. And then I'm going to reduce if I can. And 16, I think, is the biggest number that goes into both of these. I'm just kind of helping you out here. Oops, I'll put equals. So 64 divided by 16 is 4. 400 divided by 16 is 25. Now from here, we want our scale factor. Now our scale factor, we take the square root of both of those. So we're going to have 2 over 5. And then your last step is to write your proportion to find that missing side length. So we're going to have 2 over 5. Okay. We don't know the smaller side length, so we're going to call it x over 40. And now we just cross multiply. So we're going to get 80 equals 5x. Divide out x equals 16. So our final answer here, scale factor, 2 over 5, x equals 16. Boom, roasted, done. Okay, last one here on the bottom, kiddos. The area of one side of a skyscraper is 90,000 square feet. The area of a corresponding side of a scale model is 200 square inches. If the skyscraper is 720 feet tall, about how tall is the model? Okay, can you draw out a picture? Sure, just draw a big one. Area equals 90,000 feet squared. It has a side length of 720 feet. Our little model here has an area 200 inches squared, and we're looking for the side length. Okay, so it starts off just like the ones we were just doing, so we know both of the areas, and we're looking for the side length. So start with the ratio of your areas. So 200 over 90,000. Reduce because we can. This one reduces to 1 over 450. Okay, from here, we want our scale factor, so we take the square root. Square root of 1 is just 1, that's nice. Square root of 450, we'll round to 21.2-ish. And then from here, folks, write your proportion. So 1 over 21.2 equals x over 720. So 720 equals 21.2x. Divide out x equals 34. So the side of our little model here is about 34 inches. Whew. And that's a wrap, folks, on notes for this chapter. As always, thank you so much for watching and coming to for getting to this point in the video. I think it makes your life and my life much easier when we're all together in class. Adios. See you soon.